Good morning. Myself Binesh Salvanesan. I am going to handle digital electronics subject for you. So first we are going to discuss about what is digital electronics. So digital electronics is a branch of electronics concerning digital circuits which apply Boolean logic. So we are using Boolean logic to minimize the functions of Boolean expressions and obtain the circuit diagrams. Okay, so which are represented by electronic logic gates. So the minimized outputs are represented by the logic gates, and it has only two values, either 0 or 1. So we can say it as 0 is false and 1 is true. Then the digital circuit is less vulnerable to noise, and it is invented in the 20th century. Okay, so Mr. George Boole has introduced this Boolean algebras, okay, for digital electronics. So digital electronics is mainly classified into 5 sections. So the first unit is digital fundamentals. Then we are going to discuss about the combinational circuits, then sequential circuits, then asynchronous sequential circuits, then finally memory devices and digital integrated circuits. Okay, so in the digital fundamentals, we are going to discuss about the Boolean algebra, the minimization of various Boolean functions and those things. And in combinational circuits, we are going to discuss about the arithmetic circuits. In sequential circuits, we are going to discuss about counters and shift registers. Then in fourth unit, asynchronous sequential circuits, we are going to discuss about the asynchronous sequential circuits like pulse mode circuits and fundamental mode circuits. Then we are going to discuss about the RAM, ROM concepts and CMOS designs, everything. Okay, so these are the 5 units we are going to study about this digital electronics subjects. Okay, so in first unit, we are first going to discuss about the number system. So number system is a common pattern of writing the numbers. Okay, so mainly here we are going to discuss about 4 types of number system, that is decimal, binary, octal and hexadecimal. These are the 4 different types of number system we are going to discuss. So decimal, binary, octal and hexadecimal. So first we are going to discuss about decimal number system. So decimal number system has 10 values from 0 to 9. So if larger values are needed, we are going to add some extra columns in the left hand side. So that if you want to write 10 means we got to add one extra column, then 10 will be we can write the 10. Okay, so likewise so we will write everything. Okay, for example, if you want to write 10, the number is 0 to 9. If you want to write 10 means we will add one more column to the left hand side. Okay, so 10 to 19, then 20. So after 99 again we can write add one more column, so it will becomes 100. Okay, so likewise we will add next column, left side one column, then the extra numbers will be added. Okay, so each column value is 10 times the value of the column to its right. So for example, the decimal value 22 is written as 22. That's 2 tens plus 2 ones. Okay, so this is decimal number system. Then next one is binary number system. So binary number system has only 2 digits, 0 and 1. So again the same procedure will continue. Okay, for writing 0, we will write like first digit is 0, then second digit is 1. Second digit is 1, then third digit is 1 0, then 1 1, the next digit is 1 0 0, then 1 0 1, then 1 1 0, then 1 1 1. Likewise it will increase. Okay, then next digit is 1 0 0 0. So likewise it will increase. Okay, so each column value is now twice the value of the column to its right. Okay, so already I wrote this example. Then the base 8 values contain 0 to 7. Okay, the base 8 will contain the values 0 to 7. Then hexadecimal value. So it's the final one. So hexadecimal value actually have 0 to F. Okay, the number varies from 0 to F. That is, we will mention as 0 to 15. So 0 to 9 we will write the numerical value. Then A to F. Okay, 10 to 15 will be written in alphanumeric value. Okay, so the equivalent of 10 can be written as A, then 11 is B, 12 is C, then 13 is D, 14 is E, and 15 is F. Okay, likewise we will mention the number system, different types of number systems. Okay, so next we are going to discuss about the octal to decimal conversion. Okay, convert this number 126 base 8 to decimal. We are going to discuss about this number system conversion. So 126, we are going to convert this 126 to decimal number. Okay, so the 126, okay, so 126 is nothing but this right hand side LSB number is, the 6 is 8 power 0. Okay, 6 is 8 power 0, and this 2 is 8 power 1, and this 1 is 8 power 2. Likewise it will increase. Okay, the left hand side order will be increased. So 1 into 8 power 2 plus 2 into 8 power 1 plus 6 into 8 power 0, that's the decimal equivalent. Okay, so 64 plus 8 plus 1, so the answer is 86. 64 plus 16 plus 6. Okay, so 1 into 8 square plus 2 into 8 power 1 plus 6 into 8 power 0. So 1 into 8 power 2 plus 8 into 8 power 1 plus 6 into 8 power 0. So 64 plus, sorry, this is 2. Okay, 2 into 8, so 16 plus 6, 6 into 8 power 0, so 6 into 1, that is 6, so 86. The final answer is 86 base 10. So this is the conversion of octal to decimal. Okay, then binary to decimal. We are going to convert this binary number to decimal number. So 1101 to decimal. Okay, 1101 to decimal. The same procedure will be followed here also. See this 1 into, like this, 1 into 2 power 0. Okay, 1 into 2 power 0. Then next one is this 0 into 2 power 1. The next one is 1 into 2 power 2. Then finally again 1 into 2 power 3. Okay, so the equivalent value is 1 into 2 power 0. So 1 into 1 is equal to 1. Then this is 0. Then 1 into 2 square is equal to 4. Then 1 into 2 power 3 is equal to 8. Okay, so 8 plus 4 plus 1. What is the value? 8 plus 4 plus 1. 8 plus 4 plus 1 is 13. Okay, so the final answer is 13. So this is the conversion of binary to decimal. Okay, binary to decimal conversion. The next one is hexadecimal to decimal conversion. This is also like the same way. Okay, like the same way we need to convert this one. So for example, this D is mentioned here. So D is actually 14. Okay, so 14 into 16 power 0. Okay, 14 into 16 power 0. Then 2 into 16 power 1. The next one is B is 11. Okay, so 11 into 16 power 2. So the values will be 2816, 32 plus 13. Okay, so 2861 is the final answer. So this is hexadecimal to decimal conversion. The next one is decimal to octal conversion. Okay, decimal to octal conversion. So decimal to octal is very simple. Okay, so you have to divide this number 86 by 8. Okay, so while dividing 86 by 8, we will get 10 into 8 is 86. Okay, so 80. So we will put 10. The remainder is 6. Again multiply this with 8. So we will get 1 and the remainder is 2. So we need to write the answer from the bottom to top. Okay, from the bottom to top. So from here, this 1 to this 1 to 6. Okay, that's all. So 1 to 6. The answer is 1 to 6. This is decimal to octal conversion. Then next one is decimal to binary conversion. This is also the same steps we have to follow. We need to divide this 13 by 2. Okay, so we will get 6 and remainder is 1. Again divide this with 2. We will get 3 and the remainder is 0. Again divide by 2. So we will get 1 and remainder is 1. Again divide by 2. So we will get 0 and the remainder is 1. Okay, so 1101. The answer is 1101. So the equivalent of 13 is 1101. Then decimal to hexadecimal, again the same steps. Okay, 2861 divided by 16. So we will get 178. The remainder is 13. So equivalent is D. The next one is 2 and D. So B to D. So these are the conversion of decimal to hexadecimal. Okay. So this is next conversion is binary to hexadecimal. So this is very simple. Okay, binary to hexadecimal is very simple. Look at this table. So here the decimal is 0, the equivalent binary is 0, 0, 0, 0, and the equivalent hexadecimal is 0. Okay, so up to 9 there is no difference between decimal and hexadecimal. Then after 9, that is from 10, value number 10, it is 1010. In hexadecimal we need to write this as A. Okay, in hexadecimal we need to write this as A. Then 1011 is B, C, D, E, F. Okay, so this is a table we have to study. Okay, then so for example, if a number is given, okay, 110101110101. Okay, so you have to split this number from the right hand side. So from the right hand side, split this number as a 4 digits. Okay, so split this number from to 4 digits number. So 0101. So first is 0101, then 0111, then 1101. So the equivalent of 1101 is okay, split it as 4 bit nibbles. So 0101 is 5 and this one is 7. Okay, then 1100 is 12, then 13. Okay, this is 13. 13 is equivalent is D. Okay, so D75. The equivalent of this number is D75. So this is binary to hexadecimal conversion. Okay. So a big number is given. So split this number from the right hand side. Okay, from the right hand side to 4 digits. From 4 digits nibbles. So write the equivalent value. So D2956 is the answer for this one. So binary to octal is also similar. You got to split the binary number into 3 digits. Okay. So for hexadecimal we got to split into 4 digits. For this one we got to split this one into 3 digits. Okay. So 110, 101, 110, 101. So the answer is like this. So hexadecimal is to binary is vice versa. Okay, hexadecimal to binary is vice versa of the tab position. So we have to write the number, then we have to write the equivalent binary value for this number. So for A, we have to write this as A for A. We have to write 1010. Then for E, 1110. Then for 0011, then 1001, then 1111. Okay, for this we have to write like this. Then hexadecimal to octal is, first we have to convert this hexadecimal into binary. Okay, first we have to convert this hexadecimal into binary, then split this binary number into 3 digits. Split this value into 3 digits. Now write the equivalent octal value for this. Okay. Thank you.